Hello students, in today's class we are going to learn about methods for maintenance and preservation of pure cultures. So basically we have already learned what are pure cultures. Pure cultures are basically growth of one particular strain of organism that has been isolated from various sources. Now, once the isolations are done, they have to be maintained into stock culture collections. So, stock culture collections are basically laboratories which maintain large collections of strains, and there are various methods of maintaining these strains. So, why do we need to maintain the strains? Basically, for use of these strains for laboratory classes of or and research works. So, we need to maintain live culture which is uncontaminated and to prevent any kind of changes in the characteristic of the culture that is preserved. So, this is the basic purpose of the stock culture correction. So, these are the four common methods that can be used for culture preservation. First is periodic transfer to fresh media. Second is preservation by overlaying culture with a mineral oil. Third is by lyophilization. Fourth is cryopreservation. So the first method, that is periodic transfer to a fresh medium. So it is nothing but subculturing. So we have growth of an organism on a petri plate or on an agar slant, and at regular time intervals we just pick up some growth and transfer it to a fresh medium. Generally this subculturing time is about a week. However, it may vary. The time may become slightly longer if we are storing the media or the culture at a temperature or in a medium that is not supporting rigorous growth. Okay, so at low temperature in a fridge, it can be stored, or having a medium that is nutritionally less rich will slow down the cell division process. So that can be used. So coming to the disadvantages, it is a tedious method because you need to handle a lot of tubes, do the subculturing. But after a long period of time, because of continuous cell divisions, it might lead to change in genetic characteristic of a strain. So this is a problem. You don't want any mutations to be happening in your culture. You want that the culture should be having their original characteristics. Now, sorry, coming to the second method. Second method is preservation by overlaying the culture with mineral oil. So here what we do is first we need to have the growth of the particular organism on an agar slant, and we cover it with a sterile mineral oil. So what this does is, this is basically done in order to further decrease oxygen diffusion, and hence the rate of multiplication will be quite slow. Okay, so you need to do again subculturing. So in subculturing, what you do is, from the, so this is the oil layer, and from the you put a nichrome loop under the oil and scrape some growth, and then you can put it on a fresh medium which you can use for whatever experiments you want to do. So again, subculturing is required, but it may vary from species to species, and sometimes it can be even as long as 2 years subculturing time. So it is slightly better than regular weekly subculture as we seen in the first method. So advantages: you can remove some growth from under the oil with a nichrome loop or a needle and inoculate a fresh medium, and it is a simple method. Disadvantages is that cells are still here, even though the cells are dividing slowly, but still they are dividing, and it again may lead to change in characteristics. Then the third method is known as freeze drying or lyophilization. This in this method, what we do is we take a dense suspension of cells and we put it in a small vials, and we freeze it at about -60 to -80 degrees Celsius, and then the Then these vials are put in an equipment which is known as a lyophilizer. Okay, so what this lyophilizer does is, in it the vials are connected to a high vacuum line. Okay, so this helps to remove the water that is frozen and in the form of the ice. It removes it by sublimation process, and it directly gets converted to water vapor. So at the end of the process, what we are left with is some powder like this. So the powder is also because of the medium that we make use of, and plus the cells are in a dehydrated state in the lyophilized uh, powder. So advantages that is that the bacteria in a lyophilized state can stay viable for very long time, even 30 years or so they can be stored, and they have a very minimum storage space requirement. Um, they can be, these vials are basically sealed in vacuum, and the upper space is often filled with nitrogen, which is an inert gas, and then they are stored in a refrigerator. And it is also easy to, because the vials are small, they can be easily sent by mail to other labs. And whenever you want to use it, the lyophilized vials or the cultures need to be rehydrated, and then you need to put it in a suitable growth medium. Then coming to the last method, that is storage at low temperature. So here we basically need to prepare a mixture of cells, dense suspension of cells in a medium containing cryoprotectant. The commonly used cryoprotectant includes glycerol and DMSO. The mixture is put in these kind of freezing vials, and then they are just kept in a deep freezer at about minus 80 degrees Celsius. Alternatively, liquid nitrogen refrigerators that can have a temperature of minus 196 degrees Celsius can also be used. So one advantage is, or why we make use of cryoprotectants is basically they will prevent the cell damage due to ice crystal formations during the subsequent thawing process. So advantages, it will allow long-term storage for unlimited number of years. Okay, so it can be forever unless you are, as long as you are maintaining the cells in minus 80 freezer, they will stay alive. Disadvantages is that, especially if you're using a liquid nitrogen refrigerator, then you need to replenish the liquid nitrogen at a regular interval, so that becomes costly. And also minus 80 deep freezer you need, otherwise if you're not using a liquid nitrogen refrigerator, that is also costly. So these are the disadvantages. However, this is one of the best method, that is known as cryopreservation. It's the best method for storage of cells, and here you don't even need to reconstitute your cells. What you need to do is like whenever you want the cells for your experiment, you just prepare your media, and you just remove the vials and just scrape off a little bit of ice or culture from the frozen vials, and just streak it onto a fresh nutrient plate, and you can put the vial back in the freezer. So that is how cryopreservation will work. So that's it about different methods for storage of cultures. I hope you like the content. Kindly like, share, and subscribe if you like the content, and to get direct updates of the uploaded videos. Thank you.